Okay, so we're going to look at our first conic section, which is about circles. Now, conic sections in general are just a series of curves that actually come from two cones that intersect at a point. So a cone, if you recall, kind of like a funnel or something like that, kind of has a circular bottom and then meets at a top. So if you meet two of these, we have these intersecting cones, and if you take different sections of these, you have what are called the conic sections. Okay? So if you cut straight across here, what you see, if you were to cut across there, you would see that this section you cut would be kind of a circular kind of object. Okay? So, less important than that really is how we deal with those things, how we graph them, what their equations look like. So we will do circles, parabolas, ellipses, and hyperbolas in this section. So the first thing is, what is a circle? Okay. Everyone's seen circles, knows circles. What exactly is a circle? A lot of people would say it's round, things like that, all of which are true. But the true definition of a circle actually comes from our definition of distance. And what the definition is going to be, a circle is a set of points equidistant. Equidistant just means the same distance from a given point. So, it's all the points are basically the same distance away from a given point. And that given point we call the center. Okay, so here's my center of my circle. So if I take all the points that are the same distance away, so this distance is the same as this distance, 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 you get a circle. And remembering from geometry, we call this distance the radius. Radius is this distance. This distance is the same all the way around from the center to the edge of this circle. Well, if we're going to plot this, and we want to plot this in the xy plane, every circle actually has an equation in xy. So the equation of a circle looks like this. The equation of a circle with center hk, so we have a center of hk and a radius r, is given by x minus h squared plus y minus k squared equals r squared. This is called the standard equation of a circle, or standard form of a circle. You'll notice it's x minus h and y minus k, and those are the two parts of my center, and then it's my radius squared. Okay. So I can use that to write equations and also talk about circles pretty easily. So what is the equation of this circle shown below? So the first thing I try to figure out is, where is the center of this circle? Somewhere around here. Now I did graph this on Desmos, which you can as well, because Desmos does graph these kind of conic sections very well. So the center is negative 2, 1. That's our center, so that's our HK. Now our radius would be any of these segments that go from the center to the edge. That would be a radius there. But also this would be a radius here. So if I think about this radius, I'm going from 1 to 3, because this is 3, and down here is 1. So the distance from 1 to 3 is 2. So essentially what I have is, I have a center of negative 2, 1, and I have a radius of 2. So my equation is real simple in this case. It's x minus h, so it's x minus the first part of my center. So x minus negative 2 is going to be eventually plus 2, but we'll just write it as it's seen. So x minus minus 2 plus y minus 1, because we're subtracting the second part, squared equals the radius squared, and the radius is 2. So 2 squared. So if I clean this up, 2 negatives is a positive, so this is x plus 2 squared plus y minus 1 squared equals 4. So this is the standard form equation for that circle in the picture. So if I put this equation into Desmos, which I certainly can, it will give me this picture. Now, very interesting though, you see the center was negative 2, 1, but if you look in the equation, it is the opposite, and that is by design. All right, let's look at another example. Find the equation of a circle with center 2, 3, so there's our center, and passing through the point 4, 8. So if I look at just kind of a quick sketch, I have a center of 2, 3, which is here. So this is my center, but it's going to pass through the point 4, 8. So that one is way up here. So the circle is going to go around this point somehow. But I know that because it's a circle, this distance has to be a radius. But I don't know how long that is. So I really want to find out what is the distance from this center, 2, 3, to this point, 4, 8. So 4, 8 is this point, and the center is 2, 3. Well, since it's a distance, this is where we can use our distance formula from the last section. So we said d equals square root x1 minus x2 squared plus y1 minus y2 squared. So we can simply take advantage of this to figure this one out. So if I plug them in, the first x, I'll start with the center. So I could say 2 minus 4 squared plus 3 minus 8 squared. So if I work this distance out, that's going to be negative 2 squared plus negative 5 squared. That's going to be 4. And that's going to be 25. So this distance is the square root of 29. So this radius of this unknown circle is square root of 29. So writing the equation of the circle is really simple. Once you have the radius and center, it's nothing really to it. Because remember, our equation is x minus the first part of the center, so x minus 2 squared, plus y minus the second part of the center, so y minus 3 squared, equals square root of 29 squared. But if you square a square root, then remember those cancel out. So this would just be 29. So this is a circle that has a center of 2, 3 and passes through the point 4, 8. And if you wanted to check it, you could put this in Desmos, and it would certainly work out just fine because it would give us that same center and that same point. Now, the standard form of the circle is really simple to use. It gives you the center, it gives you the radius. But when you talk about other kinds of equations, there is another form of a circle, which is called the general equation of a circle. Now, the general equation of the circle is any equation in this form. Any equation in the form x squared plus y squared plus ax plus by plus c equals 0. So essentially everything is expanded. You have an x squared, you have a y squared, you have something x, something y, plus a number equals 0. And some of these could be 0. So this is a much more kind of odd way to see a circle, but if I said, hey, look, here's an equation, x squared plus y squared plus 2x minus 4y minus 7 equals 0, that would be the equation of a circle. I don't really know what the radius or center of that circle is, but I will be able to find it eventually. Okay? So let's look at an example. So here we have an equation written in really nice standard form. If I want to know what the center is, I could figure that out. Remember, the center is always the opposite of this. So the center would be -2, opposite. And the opposite of -4 would be 4. And it has a radius. Now remember, this is r squared. So if I take the square root of 64, the radius is 8. So since we squared it to put it in to get it back out, you just take the square root. But I want to put this in general form. I want it to look like this up above. Well, we can do it though, because how it becomes that is if you think about this, I can write x plus 2 squared just twice. I can write y minus 4 twice, because they're squared, equals 64. Now x plus 2 is just going to take advantage of our foiling. So x squared plus 2x plus 2x plus 4. I could FOIL this other one, y squared minus 4y minus 4y plus 16 equals 64. And then if I put some stuff together, I have x squared plus y squared, those are these guys. I have 4 x's, those are those guys. I have -8y. And then I have 4 and 16, which is 20, equals 64. And then I'll simply move the 64 to the other side to get it in general form. So x squared plus y squared plus 4x minus 8y minus 44 equals 0. So this is the general form of this circle. Now if I look at this, there is no way I'm going to know that this has a radius of 8, and there's no real way I'm going to know it has a center of this. So this form is not quite as useful to us. So what we're going to try to do is we're going to try to take things that look like this in this horrible, horrible form and make them look something more like this. So to do this, to change from general form to standard form, we are going to use a thing that we've used earlier this year, which is called completing the square. Okay. So if we look at this example, here is this horrible, horrible equation that is in general form. So I want to basically make it look something like this, where it's x minus h squared plus y minus k squared equals r squared. Okay. So here's how we'll go about doing this. So really how I FOILed it and got it into general form in the other one, we're going to do the exact opposite. So I'll first add 12 to both sides to get the number on the other side. And then I'm going to put everything that has an x next to each other. So I'm going to make x squared minus 4x next to each other. I'm going to make y squared plus 6y next to each other. And then I'm going to put 12 on the other side. Now here is the key step. This is what you really need to know for completing the square. I am going to look at this number for x. And I'm going to take half of that. What is half of -4? Half of -4 is -2. And then I'm going to square that number. So I'm taking -4 and I'm cutting it in half. And I'm going to square it. That is -2 squared, which is 4. So I'm going to add 4 to this side. So I will add 4 to this side. This is a technique we used back in Module 5 when we were doing quadratic equations, called completing the square. And then I'll do the same thing for y. I'll look at the 6. 6 cut in half is 3 squared. So 6 divided by 2 is 3. 3 squared is 9. So I'll add 9 to both sides. Now the benefit of this is I look at these 3 and I factor those 3 together. And then I look at these 3 and I factor those 3 together. Well, if I factor this polynomial, If I'm looking for two numbers that multiply to positive 4 but add to negative 4, that would be negative 2 and negative 2. And if I look at two numbers that multiply to 9 but add to 6, that would be 3 and 3. And then everything on the other side, I can just say 12 plus 4 plus 9 is 25. But you notice they factored as the same thing twice, so I can write it as x minus 2 squared plus y plus 3 squared equals 25. Hey look, now it's in the same form that we had up here. It's x minus something squared, it's y minus something squared equals a radius squared. So the center of this circle is going to be the opposite of that, so it's going to be 2, and then the opposite of that, which is negative 3. Remember, coming out or going into the equation is always the opposite. And the radius is going to be the square root of that number, so the square root of 25 is simply 5. So by completing the square, it really gives us the ability to find the center, find the radius for something that's written in this kind of more generic form of general form. Okay, so the last problem says find the length of the diameter in the following circle written in general form. Now if you remember diameter is just through the center all the way across, so it's basically just 2 radii. So if I can find the radius, I can put this in general form. So I have 3x squared, so I'll rewrite this in a little nicer form. So I'll put the x's next to each other. There's only one y, so I'll just kind of write it by itself. And I'm going to subtract the 4 to the other side. Now the problem with this is we cannot complete the square when it has a number like 3. So what I have to do is I have to divide everything by that number 3. And it will divide by everything on the left side, because if it doesn't, then this isn't a circle. So I divide everything by 3, and you'll notice I get x squared minus 4x plus y squared equals negative 4/3. And now I'll do my complete the square. Now this is actually the exact same as the one above. So if I take half of negative 4, I get negative 2. Negative 2 squared is 4. So I'll add 4 to both sides. I don't have to complete the square on y because there's only one term, so I'll just leave it like that. So these two will factor. Two numbers that multiply to 4 add to negative 4 are negative 2 and negative 2. So x minus 2 plus y squared. And then if I do 4 minus 4/3, you can do it in the calculator or you can get your common denominators either way, but it's going to be 8/3. So this could be written as x minus 2 squared plus y squared equals 8/3. Now I know this problem doesn't ask for it, but we could still pick out the center of this problem because now we have it in standard form. So the center is going to be the opposite, so it's 2. Now there's nothing here. There's no y minus anything, so we just say it's 0. If it's just y squared or just x squared, then that part of the center is just 0. And the radius, remember this is r squared, so the radius is the square root of 8/3. So in this problem, we know this radius is square root of 8/3, and this is square root of 8/3, so for our diameter, it would just be 2 of those. So the diameter is going to be 2 square root of 8/3. So whatever that weird, awkward, irrational number is, that would be our diameter of our circle. Okay, so go ahead and try the assignment. Please let us know if you have any questions on circles.